Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
I'm Jacob. For math homework help, call in Bakersfield 636-4357 1-866-636-6484. No.
Or email. How can they email us if they need to get a hold of us?
Or email dothemath@kern.org. We're online at dothemath.online.
That's all right. You got it. You got it. All right. So what's our website again? You get Do the Math Online, and what's the ending?
.net.
There we go. And then can they find us on social media? Where at?
And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done, Jacob. Thanks for doing that. Otherwise, Mickey would have had to do all of that stuff. So,
Yeah.
Jacob, where do you go to school and what grade are you in?
Well, I go to school at Whitley, 3rd grade.
Okay. And how is third grade?
It's fine.
You like it?
Yeah.
And what's the best thing about third grade? You can tell me.
Recess.
Yeah, recess, right? Recess is always the
Yeah.
best
All right.
thing,
What's your
right?
favorite thing to do at recess?
Basically hang out with my friends.
Best part
That's
of
what you're
recess.
supposed to do, right?
Absolutely.
All right. Well,
Good
good. I'm
stuff.
glad that third grade is going well for you so far. We're going to take a look at some of your work today, and we're going to work on some of that. Sound good? First, I need you to help me out with today's social media problem of the day. You ready to do that? All right. Let's take a look at the monitor together up there. And it says the math problem of the day. It says, what is the answer? Now, it says parentheses 5 plus 5 plus 2 plus parentheses 2 plus 2. Now, have you ever seen a math problem with those parentheses around the numbers?
Yeah.
Okay, so what do you think we should do in order to solve that problem?
Well, first we should do the 5 plus 5.
And what do we get then?
10.
Okay, and then what would you like to do?
Then add 2 plus 2, which would be 4.
Okay.
And then add 10 to 4.
And that gives us.
14.
All right.
Then you would add 14 to 2. That would give us a total of 16.
I like that you said total there. A lot of students might just say, oh, it is 16 or it equals. I like that total. A nice academic word students will see in word problems. I like that you recognize that. Nice word.
So you're feeling good about that?
Yep.
You sure it's not 10?
I am very sure.
I kind of 31's kind of cool. I mean 31's kind of an intriguing number. I don't know if it works or not, but it just looks cool. You sure you want to stick with 16?
Yes.
All right.
All right, let's take a look, see if indeed you are correct. All
Boom,
right,
there we
see
go.
16, first one done, dude. See how easy that was? All right. 636-4357 is the phone number. We do have phone tutors available Tuesdays and Wednesdays throughout the regular school year. Programming note, next week, the 19th and 20th of this month will be the final live broadcast week of Do the Math, our 22nd full year. Can you believe that, Mick?
Yeah, I've been here for a lot of them. Yeah, or at least I've been around for most
You've
of them.
been around for them all, but yeah, 22 full years right there, coming to an end next week. Not that the show is ending, it's only ending for this season. All right, time now for today's Math in the News. All right, so right now, today's Math in the News. Jacob and I are fortunate enough to have Andrea in studio with us today. How are you?
I'm good. Good
Nice to have you with us.
Thank you for having
And
me.
you are with Kern Dance Alliance.
Kern Dance Alliance.
So for folks out there that aren't familiar with the Alliance, tell them a little bit about it.
Yeah, so KDA is a nonprofit arts agency. So we host a series of different arts education programs available to all people living in our community. Similarly, we also offer opportunities for artists and arts agencies to build their capacity. And what that means is we provide them with financial services, we provide them with professional development, we create jobs that pay them to do work in our community.
Okay.
And it's really all about using the arts to make life better for people living right here in the Central Valleys.
Which is why STEM has turned into STEAM now.
That's right, because we understand that it takes a creative mind to solve those difficult problems.
And I remember when you first started out, you were here on the show to talk to us all about it. So how long has Kern Dance Alliance been around now?
We will celebrate 10 years
Yeah,
in
there you go.
2025. So we're year 9 this year, and we have made some really incredible impacts through the programs that we operate
Well,
in our
congratulations on
Yeah.
that. So Jacob is here to help us out, and we're going to talk a little bit about some math and dance.
Yes, so KDA operates a program called Shine for Girls, Math plus Dance equals Success.
Okay.
And the program started by an MIT graduate on the campus of Cambridge, Massachusetts. And she was frustrated that not more women were going into STEM careers. And she was a Bollywood dancer. She was of classical Indian descent, and she said, most girls like to dance. I wonder if I can allure more girls to STEM through dance. And so she created the very first Shine for Girls program on the campus of MIT.
And it's been working.
And it's been working. It's been in several other cities and states. Girls come into the programs with D's and F's in math, and they leave with A's because somebody has taught them math through their body. Algebra, pre-algebra, probability, kinesthetic learning.
All right, so Jacob and I are boys, but you're going to help us out with this.
That's right.
Okay.
So just to be clear, we know that research kind of shows that girls make it or break it in terms of their confidence in STEM in junior high. This program is for junior high girls. We want to keep their confidence blazing so that they believe in themselves to go after. Boys are wired a little bit differently, but today we're just going to call it our math and dance program, and we'll leave the boys and the girls out of it.
All right, let's go.
Okay, so today we're going to do the expressions dance. Jacob, have you been learning about expressions in school yet?
Not really.
That's
Yeah, not
okay.
yet. Third grade, so
That's
he'll get it next year,
okay. But
probably.
you know what? We're going to teach him something new, and he's going to remember it because he's going to learn it through dancing.
Perfect.
Perfect. Okay, so just to be clear, there's a difference between expressions and equations. Do you
Right.
know the difference?
Well, the equal sign.
That's right. There's an equal sign in equations, but
I
not
didn't
in
know I was being quizzed today, Andrea. I thought we were going to dance and talk about Kern Dance Alliance, but it's all right with the quiz. Keep going, sister. Let's go.
So this is good. So yes, an equation, or sorry, an expression does not have an equal sign. However, an equation does. We're not going to mess around with that equal sign today. We're just going to solely
Now,
focus
what
on
if we
expressions.
nail the expressions? Can we step it up to?
Well,
I'm only kidding. Let's
I'll
just
be
do the
hon-
expressions.
Okay,
so
all
we-
right. So here's what we're going to do, Jacob.
Okay.
We are going to put an expression on the board, okay? So Mrs. Hansen's going to write it first, but you're going to help me define our variables. I'll tell you more about that in a minute. So let's just use, for purposes of today, we will do 2x plus 3y plus z. So these variables are unknowns in our expression. They really could represent anything. Values, they could be animals, they could be different types of flags, but today we're going to define these variables as dance movements. So this is where our creative brains are going to come in, and that's going to help us understand how to solve this expression. So, Jacob, do you have a favorite dance move?
Not really.
Do you have any kind of dance move that you like to do?
Well, if you call the Irish River Dance a dance.
Ooh, let's see what that looks like. Let's show the camera. Okay.
Oh, easy, dude. I didn't know we had professionals
Can
in
you
here on that
manage
day.
this too? Shall we practice with him? Come on, hands behind the back. Here we go.
See
Let's
there.
try it. Here we go.
Doing a jig. St. Patrick's Day is coming up.
This is perfect. Okay, we're calling this the Irish jig, basically. Is that kind of what it is? Okay.
Irish, really.
Irish.
And it is St. Patrick's Day.
It's perfect. So we're going to call it, what did you call it? The Irish River Dance?
Yeah.
Okay, the Irish River Dance.
Real thing, actually.
It sure is. Have you seen river dance before?
Yeah.
They're pretty impressive. Okay, the Irish River Dance. You got that?
Got it.
Okay, now let's define our why. Your turn. Any kind of dance movement you want to come up with.
Oh, well, I got a few of them, but we're just going to go with something Two-step.
A two-step. Are you going to show us how to do the two-step?
You're going to teach me how to do that. I know there's such a thing as a
It
two-step.
depends. Are we doing a country line two-step? I mean, there's all different types of two-steps out there.
What kind of two-step would be the easiest for us to do?
Let's do this. So, gentlemen, we will go 1 and 2. Can you do that?
That's still more than two movements.
Oh my gosh! Well, it's you asked for a two-step. I should.
All right, well, let's go.
Two-step.
Let's
Here
try
we
it,
go.
Jacob. You
Step
ready?
with your right foot. We go right and right, left and left.
All right.
Try that again
So
one
we're
more
doing
time.
2 each way then.
Yeah, that's right.
All right.
Okay, but we will call that for purpose. Right, left will be 1. All right, here we
Gotcha. All
go.
right, here we go.
Right and right, left and left. So can we practice our Irish river dance really quick?
How long are we going to do that one?
Well, we will go.
A count of 3 or something?
Yeah, this is good. Let's
Count
go.
of 2?
Let's go. 1, 2, 3. 1, 2, 3.
All right.
Getting really fancy. Okay, so let's do our Irish jig. Here we go. A 1, 2, 3. A 1, 2, 3. Followed by your two-step. Right together, right. Left together, left. Woo! Okay, all right. So that's our two-step. You guys are good. This is a lot more complicated than I was expecting it to be. And Z, I'm going to define that. I'm going to keep it really simple. Can you just give me one hop? Done. That's a hop. Okay. So we have defined our variables.
All right.
So this is where
I thought we were looking for like high tech, you know. Like, all right, we could have kept it simple, I guess. But all right, let's do what we've got.
this is what we're going to do with
Okay.
that. So in this expression, we know that the X is your Irish river dance. We know that the Y is your two-step. And we know that the Z is a hop. Now, because we have these numbers in front, we have to repeat those steps that many times. Does that make sense? So,
Well, here's what I say we do.
What do you want to do?
Let's switch some of these around.
Well, what do you want to do?
Well, let's switch these two.
Okay, you want to put the hop in the middle? And then finish it off with the
Because
two-step?
otherwise, we're moving around too much like that.
All
You see what I'm
right.
saying? That way we can kind of stay stationary.
Hey, you guys are pros. You guys are pros. You can handle this. Okay, one hop, and then this is our two-step.
But we're going to be doing 3 hops.
That's right.
That's what I'm saying.
Good.
All
So,
right.
shall we practice? So we decided 1, 2, 3 was one Irish jig. How many times do we have to do that Irish jig?
2.
Good. Let's do that
All right,
2
here we go.
times.
Do we have to put our hands behind our back?
Yeah.
I think that's what he showed us. Shall we try?
We'll
Here
try it.
we go. And 1, 2, 3. A 1, 2, 3. All right, that was 2 jigs, or Irish river dances. Okay, now how many hops are we doing? 1, 2, 3. Can we practice?
Let's go.
Here we go. And 1, 2, 3. All right, now finally, is there a number in front of this? 0. However, there is still a variable there, which indicates we have to at least do.
So instead of a 0, let's just consider it a 1 in front of it. Otherwise, if it was a 0, we'd have Oz and we'd be doing nothing except thinking about Dorothy. I'm like,
Perfect. So we've got to do this two-step
Okay.
once. And if you recall, that was right, left, right, left, right, left. Here.
You got us.
Here we
Right,
go.
right, left, left.
Basically.
All right,
Perfect.
here we go.
And da, 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 and da, 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 da. Okay, now
All
we
right.
have to put this whole thing together.
So we're going to give this one shot and we're going to see how we do.
That's right.
All
Are
right.
we ready? Okay, we have 2x plus 3y plus z, which means 2 Irish river dances, 3 hops, followed by 1
One.
two-step. Can you put this all together with us? All right. Shall we put them in the
All right,
middle?
so let's go this way.
Let's put you in the middle. Perfect. Are we ready?
Ready?
Here we go. 2 Irish river dances. Go. A 1, 2, 3. A 1, 2, 3. 3 hops. 1, 2, 3. Two-step. 1 and 2 and a 1 and 2. Come on back.
There we go.
Okay. Now I believe.
pretty good?
Pretty cool, right? Learning that through movement. Now I believe we have some music prepared.
Oh, we do.
Oh yes.
Oh, lovely. All right.
Shall
there
we
go.
move into performance mode, or do we need one more rehearsal?
I think we're good.
We're good.
We're good. Let's go.
Okay, so I'm gonna get. I originally had counted us an 8 in, but I will give us a 4 count in, and then we're going to go. Are you ready?
You just got us. We're ready to go.
Okay. All right. Music, go, please. 2, 3, 4. Let's go. 1, 2, 3. 1, 2, 3. 3 hops. 1, 2, 3. Two-step. 1 and 2 and a 1 and a 2. Hooray! We did
There we
it!
go. Nice job. Andrea, nicely done.
We did it.
So, Kern Dance Alliance, if somebody wants to find out a little bit more about what you do and where you're at, where do they need to go?
So kerndance.org, and we are very active on Instagram, on Facebook, and also on X, formerly known as Twitter.
And congratulations on your 9 years coming up on 10, and I'm glad that you guys were able to come here and tell us all about it when you
Thank
first
you.
started.
And you know what? It's also California Arts Education Month. The month of March, we celebrate arts education access for all in our state. So I was so glad I got to come talk to you guys about combining my favorite thing, dance, with math to create a real wholesome educational environment.
Good. Well, we had the whole body going on in that one, and we're going to take
sweating
a
a
look
little
at
bit.
a little bit of the math manipulatives right now.
Hi, I'm Marylou Long, and today we're going to explore pattern blocks. Believe it or not, pattern blocks is a great tool for teachers and for students for that conceptual understanding. When students are in TK, they're really learning about patterns. And so just simply using patterns, we can kind of start seeing colors. We can start separating by shapes. When we move into kindergarten, students are learning how to count, and that's called cardinality. The amount I count is the amount I remember, 1, 2, 3, 4. Also, what we can do is we can just put out some pattern blocks and allow the students time to count the way they want to count. How do they want to sort? Do they want to sort it by shape? Or maybe they want to make a pattern. Maybe they want to sort it by a pattern, A, B, C, A, B, C. In TK through second grade, we do what's called additive thinking, where they're really making sense and trying to put together those patterns and learning to add and subtract. When we're getting into the other grades, when we're getting into third grade, we're seeing that this repeated addition is now really turning into multiplication. Here I have 1, 2, 3, 4, right? So I have 4 groups of 1, and 4 times 1 we know is 4. Or we can break this up into groups. Here I have repeated addition, and I have 2 plus 2 plus 2 plus 2, or I am seeing 4 groups of 2, which I know is 8. So now we're into multiplicative reasoning and really trying to understand what that looks like. When we're getting even to the upper grades, we're going from that multiplicative reasoning into proportional reasoning. And what does that mean? We really need to understand what those equivalent fractions look like. If I said that these 2 shapes equal $36, how much would this one shape equal? So when we break this down, we know that each one of those equals 18. By putting both of these on, we know that these 2 have to equal 18, as well as these 2 shapes need to equal 18, because we know that 18 plus 18 equals 36. So then what does one trapezoid equal? Well, I know that 9 plus 9 equals 18, so therefore this one trapezoid needs to equal 9. So I know that both of these equal 36, and I know therefore that this one shape equals 9. What is this rhombus equal? Well, let's break that apart again. I can break it this way, where I see 3 rhombuses equal 1 hexagon. So I know this one hexagon again is 18. Well, now I have 3, and I know 18 divided by 3 is 6. So therefore, I know this one needs to equal 6. So I have 6 plus 6 plus 6 is 18. I could even break that down further. And now let's look at this with our triangles. So breaking it down, how many triangles do we now have? I know that 2 triangles equals 1 rhombus. And I know the 1 rhombus is equivalent to 6. So therefore, I know that 3 plus 3 is 6, so each one of these has to equal 3. So just understanding what that proportional reasoning looks like, starting in TK, making sense of patterns, going into that additive thinking, and then moving into our proportional reasoning. Eventually, when we start 8th grade, we're now going to get into functional reasoning. And how can we use these with functional reasoning? That is something I'm going to leave with you to think through. How can we continue to use these as teachers? There's so much we can do with pattern blocks. Get a set, check it out. It's lots of fun, and your kids will absolutely love it. Thanks again for joining me today with pattern blocks.
And thanks to Marylou for that. We have Jacob, a 3rd grade student from Whitley Elementary in school with us right now. You feeling good after the dance moves? All right, well, you're going to feel even better after we do this move right now with a little bit of mathematics. So you and Mickey head over to the board. Here's the problem. We'll look at it together. Christina put 15 vegetables on her tray. If 1/5 were carrots, how many carrots were on the tray? Make a drawing to show your work.
All right, so we have 15 vegetables on a tray, 1/5 are carrots. What are your thoughts? How do we start?
Well,
What are you thinking? It's all right. So if I have, let's say, 15 vegetables, 15 in total, but 1/5 of them are carrots. How do you think we could start to figure out how many of them are carrots out of the 15 in total?
we could divide 1/5 from that 15.
So you don't take 1/5 of it?
Yeah.
Okay, but we have to draw something, so what do you think we could draw? You're okay, try it again. Just don't let your hand touch the board. All right, go for it. And 15 divided by 5, what do you get?
10.
That's subtract, divide. So 15 minus 5 would give us 10. Aha. So one thing we need to do is, that is correct in division, but we need to verify that it works using a picture or a model, okay? So what I want you to think, because we're going to make a model or a picture based on this right here, okay? So we're going to think, okay, we have 15 vegetables on our plate, or for us to eat sometime. Maybe not all at once, but we have to eat them eventually. We need to split them into how many groups? You said divide by 5, so I would need to split them into how many groups?
5.
So what I'm going to do is I'm going to make, we can pretend it's a box of vegetables, okay? I need you to split this box into 5 compartments. Go ahead.
First, we'll start in the middle.
Okay, we got 2. Now we have 3. Now we have 4. Oh, hold on. Don't split it down the middle because that'll give us 8. Let's make one more vertical line somewhere. All right, I love it. So now we have 1, 2, 3, 4, 5. Would you agree we have 5 compartments, or we can divide it into 5 pieces like you said in your division problem? Very nice. Now what I need you to do is take the 15 vegetables and place 1 in each compartment until we've placed all 15 in our box. There's 5. There's 10. All 15? Mm-hmm. Very nice. Now, the question I have for you, 1/5 of all of these are carrots. I want you to circle 1/5 of this box.
Okay.
Go for it.
1/5 is technically one of these. So
Show me what you think. What you got?
you would circle 1 out of the 5 boxes.
Within the one that you circled, is there any evidence to prove this matches your division problem?
There are 3 in the box.
So what you just did is you took a division problem and you worked it out using absolutely no numbers written down. Can you believe that? You took an entire division problem and worked it out using lines and dots.
I can actually pretty much believe that.
That's good stuff, huh? So that's a big push now in education, is helping students realize math doesn't always have to look like numbers and operational symbols. It can be a picture or a model to show the exact same concept, and sometimes it helps students see the math rather than thinking, well, why is 15 divided by 5, or what's 1/5 of 15? 3, why? Well, because my teacher told me so, or because I just know it. Now we can begin to ask students to prove it and show me what that math looks like. So let's go over to Mike, let's see if we got it right.
Okay,
3
you got
carrots.
3, but now we have a part B to this problem.
Holy smokes, here we go, we got this.
All right.
Talk to me.
Aaron put 20 vegetables on the tray.
Whoa.
So you're going to write 20 someplace, because this is where we're going to add to this now. So we have
right.
20 vegetables on the tray.
Now are we adding 20 more?
No.
Okay, so 20 is now the total.
1/4 are carrots.
All right, we're getting spicy. Spicy carrots, here we go.
1/4 were carrots
All right,
of the 20.
Now we'll draw a box.
so you want to use the same concept?
Yeah.
Go for it.
First, we might want to draw a box,
Okay.
and we might want to make it rather large because there's going to be 20 carrots.
Need some space for 20 carrots, huh? I like it. All right, and we said we need 1/3 or 1/4? What was our number?
1/4 are carrots.
1/4.
So there's 20 vegetables, 1/4 are carrots.
So we'll need to divide this box into 4.
Okay. You do it, I'll watch. I'm ready. Boom, 4 pieces, ready to go. Next steps, talk to me.
Okay, so now we need to place all of the 20, but we have to do it with 1 in each box,
Do you know why it has to be 1 in each box?
because then we'll eventually put all 20 in each box, and it'll still be even, which makes it easier. to
So
do
it's
the
not that it's
problem.
not always easier. When we are dividing or distributing, it has to be equal and even, or a constant ratio. So it's kind of combining a lot of different terms for 3rd, 4th, 5th, and 6th grade. So I want you to go ahead and do what you were telling me. You're going to put 20 carrots into these 4 pieces, and then I want you to tell me how many carrots would we have if 1/4 of them were in there. We got 4. Got 8. And there's 12. 16. Oh, there we go. Boom. All 20 carrots distributed into the box, or 20 vegetables into the box, but we still only need 1/4 of them.
So we will circle 1/4.
All right, go ahead and show me. Ooh, got close to those other ones there. All right.
Lucky.
So how many is 1/4 of 20, Jacob?
That would be 5.
All right, let's check with Mike.
5 is correct. Now here's the final question.
Okay.
It says between the 2 of them, how many carrots were there?
Ooh. So now it's almost like we have both boxes. So if we have 2 that first box is in front of us, the other box is right next to it. How many carrots do we have all together? What are your thoughts?
Well, first we might want to subtract the totals from each one.
Okay.
So 3 minus 5 is 2.
Okay. So 2 carrots? Remember,
That
so
might
on the
be wrong.
first one, so let's just review real fast. Let's just remind ourselves. We had 15 vegetables in a box. 1/5 of them were carrots. You determined how many carrots were in the first box. How many?
How many carrots?
After you did all your division and then we verified with a visual, how many carrots were there?
3.
Okay, so we know in this one, we have 3 carrots. Sometimes writing it down helps us keep track of stuff, okay? Now on this next one, I want you to remind me, since you just did it, how many carrots were there in this box that we circled? Now I always like to be specific with my students. 5 what? 5 rolls of Smarties, 5 cucumbers, 5 carrots. Perfect. Now the question was, how many carrots do we have in total? Okay.
Well,
So we had 5 here. How many up there?
3 carrots.
So what would you say is our total?
Well, 5 minus 3 equals 2.
If I give $3 and you have 2, how much money do we have all together?
5.
So if you have 5 carrots and I have 3 and we're making carrot soup, how many carrots do we have all together? I have 5, you have 3.
8.
Ah, so how many carrots do we have in total from the 2 boxes?
What?
So I have 5 carrots from this box. You have 3 from that box. We put them together. How many carrots do we have?
We have,
Here's what we're gonna do. Watch this. So I'm gonna use 3 tally marks. 1, 2, 3. Take your 5 carrots. Show me 5 more carrots right there for me. 1, 2, 3, 4, 5. All right, count them up. How many carrots in total, sir? Ah, 8 carrots in total. There we go.
There you go.
Nice
Nicely
job.
done. 8 carrots.
Way
So
to
a
go.
great problem. We even had 2 parts to it. For your great effort today, you've got yourself a pass, courtesy of our friends at COM. So congratulations on
go
that.
check out the animals.
Hopefully you have an opportunity to go out and
Nice.
visit that. We'll be back with more right after this.
We are California State University, San Bernardino. We are more than a campus. We are a community united by a common purpose, fueled by the belief that knowledge should not only be acquired, but shared for the greater good. Together, we are shaping the present and defining a future where every moment counts.
To invest in our students, to further eliminate barriers to success, expand educational opportunities, and enrich their academic experience.
To invest in our outstanding faculty and to attract and to retain new faculty to further enhance research, creativity, and scholarship.
To advance academic excellence, to energize and expand robust programs, and create new ways to address today's global challenges.
And to modernize facilities that enhance teaching and learning and create new environments conducive to student and faculty scholarly endeavors.
A future formed by thousands of meaningful moments. Moments as powerful as mastering a relentless challenge, as rewarding as giving it all you've got, and as thrilling as achieving a lifelong dream. Collectively, these moments have made Cal State San Bernardino what it is today, a trusted leader in higher education, powered by the momentum of our talented students, our world-class faculty, and the communities in which we live. Since its founding, we have been a model for transforming lives, a driving force and vigorous contributor to the education, economic prosperity, and sustainability of the Inland Empire and beyond. CSUSB's designation as an R2 institution elevates our status as a doctoral university with high research activity. Our student body reflects the diverse, dynamic demographics of the region. With more than 80% the first in their family to attend college, we are committed to ensuring that every student succeeds. A commitment that has a far-reaching and life-altering impact. Ranked 4th in the nation by U.S. News and World Report for Driving Social Mobility, CSUSB provides reduced tuition to low-income students who then graduate into well-paying jobs, a crucial step in securing social and economic independence. Our philanthropic foundation provides $1.7 million each year to more than 700 students, ensuring that they have the critical support they need to succeed. And another $1.9 million in endowment funds support both student and faculty success. Our collaborative partnerships in the community and innovative programming provide students with internships and hands-on learning opportunities that equip them with industry-specific skills, ready to make an immediate contribution in the workplace. We thrive on the spirit of service and innovation and serve as a catalyst for positive change in the region. With more than 500 partnerships forged with the Inland Empire nonprofits, K-12 schools, businesses, and other organizations, CSUSB is renowned for its spirit of collaboration and shared purpose. Each year, our dedicated community, students, faculty, and staff contributes 100,000 hours of service, equivalent to donating a staggering $3 million to local organizations. And with more than 20 centers and institutes, we provide hands-on expertise, tackling regional challenges head-on. From navigating the complexities of water management to optimizing transportation, from fortifying cybersecurity to nurturing entrepreneurship. The breadth of our knowledge is as extensive as the issues we address. Our students learn to reason, to lead, and as graduates, revolutionize their chosen fields and make a long-lasting impact in their communities. Our alumni are prepared to thrive in any sector, from media consulting to medicine, education to engineering, public health advocacy to poetry, and everything in between. Our extraordinary faculty think critically and act boldly, achieving excellence through high-impact research, creative activities, groundbreaking scholarship, and interdisciplinary and international collaborations. Since 1965, Cal State San Bernardino students, faculty, and alumni have harnessed the power inherent in each passing moment to address challenges and implement positive changes in education, health, technology, science, policy, and the arts. Known for our perseverance and passion, we at CSUSB solve some of today's toughest global challenges by bringing out the best in every student through high-impact learning, dynamic experiences, and programs driven by innovation. It only takes a moment
to further discovery,
to conquer challenges,
to realize our dreams,
to define our future together.
Another one of the great schools in the CSU system right there. 636-4357 is the phone number. Today is Wednesday, the 13th. Next week, the 19th and 20th, the final 2 live broadcasts for Do the Math for our 22nd season.
Woo!
That's it, huh?
There we go.
In studio, we have Jacob, a 3rd grade student from Whitley Elementary. He's been doing some great work with fractions so far today.
Yep.
And did you like the dancing?
It was fun.
Yeah, it was fun, right? So you were like, yeah, we do a little bit of fun, and we do a little bit of this, a little bit of that, right? We keep the show going, right?
Yeah.
All right. So did you know that Math Week is coming up?
Right?
Yeah, I thought Math Week was all the time.
Oh, I don't know. I teach math every day. It's Math Week all week. I don't know.
Yeah.
So anyway, Math Week is coming up next week, and that is where all of Kern County and counties up and down California will be taking part in Virtual Family Math Week. And the deal behind this is that you can go ahead and you can scan that code right there, and you and your family will have activities and stories that you can partake in. And you read the stories, and along with the stories, there are games to go with them. And the key is that you guys can do these things as a family together so that everybody is partaking in that process of learning a little bit of math and having fun while doing it. So that is coming up March 18th through the 22nd. And I know they're always looking for a number of minutes or something like that the families are doing to accumulate towards a bigger total. So we'll find out what that total is, and we'll see if we surpass that this time coming around. All right, so in the Math Week, there are different games that they play. You want to try one of these?
Yeah.
All right, head on over to the board with me.
No, sorry, that's right. It's for Jacob. I'm sorry.
You're
Go ahead,
over there
Jacob.
too. All right, so this is going to be Tortuga. So we see a turtle, and we see 1 and 2 are on there already. Those numbers do not move. These numbers on the outside do not move. This is what the sums have to be when we add numbers together. So if we go 1 plus something, it equals 5. 2 plus something equals 5, but then we look at it diagonally and horizontally as well.
Whoa.
So here we can see 1 plus 2 horizontally is 3. 1 plus something is 4.
So does that make sense so far, Jacob? Is that
Yeah.
we see where the lines are at, and they kind of make the turtle shell design. So the 1 would have to add something to make the 4, but that same number has to be valid for 2 plus something to make 5, and the same 2 numbers to make 7.
So you guys are going to move the 3 and the 4 over here. Those 2 move. So you can move those to the empty spots and see if it works.
Go for it. Where do you want to put it? Oop, try it again. Yeah, there we go. All right. Oop, try it one more time. 1 finger. There we go. All right, talk me through your reasoning. Why'd you put the 4 there and the 3 on the other side?
Well, first, 1 plus 4 equals 5.
Okay.
And 2 plus 3.
Uh-oh.
Quack.
All right, there we go. So you said 2 plus 3.
2 plus 3 equals 5.
Okay, so that one's valid. Okay.
And
So if
4
you're good with
plus-
that and everything works diagonally, explain all that. When you're ready, hit the question mark and it will let you know what you're up to.
And 4 plus 2 equals 6.
All right.
1 plus 2 equals 3.
Looks good to me.
1 plus 3 equals 4.
Right on.
And 4 plus 3 equals 7.
All right, let's see. Sounds good to me. Hey, we got a smile. That looks pretty good to me. Turtle looks happy. Let's go to the next one. Let's see what you got.
Ah, you got the bell on that. There we go.
Ooh, this time instead of giving us 2 numbers, we only get 1. So go ahead, tell me what you're thinking. Let's go for it.
Well, I remember that 3 plus 4 equals 7.
Good way to start. Use something we know for sure.
And then that I know.
2 and 4 gives us what?
6.
Okay.
And then that will go there to give us a sum of 4.
All right. Let's see. Good luck. Ah, another smiley face. Well done, sir. Oh, here we go. Now we have nothing to go with. It's all up to us.
Okay, so here we are.
We got 3, 1 finger. There we go.
That's got to be correct.
Looks solid to me. 3 and 2 does make 5.
There we are. And that has to be here.
Has to be, you say. Okay. Uh-oh. Uh-oh. Ah, there we go. Well done, young sir.
All right, you've got time for one more.
Ooh, bigger numbers. Instead of having 1, now it's 2, 3, 4, 5. Compared to 1, 2, 3, 4. Okay, we got a 5.
Okay.
So we're making 8 with that?
Yep.
All right.
There.
Boom!
There
Even
you go.
faster,
Nicely
the harder
done.
it
So
gets,
you got
the
through
easier
a couple
we
of
get.
levels right there. So
Nice work.
Tortuga is just one of those games that you can play during Math Week, and there are all different levels. So anybody from kindergarten through 12th grade is going to be able to play these games. Virtual Family Math Week is coming up next week. Brought to you Math Minds, the QR code, and you can scan that right there. Scan it, download it, have fun with it. That's the whole point of it, is to have fun with math with your family, and that's one opportunity to do it right there. We'll be back with more right after this.
Fed them, clean out their pens, change out their water buckets, and give them the exercise they need to be able to be the best they can at fair.
Takes up a lot of time. I wouldn't say it's hard. Like, it doesn't seem hard to me because, like, I'm having fun.
So you have to feed them, walking, washing them. My pig doesn't like to eat, so that's a fun one.
But you made this commitment, you're here for these pigs, and you will ride it through all summer.
If these don't lock and secure around that needle, then we're not going to be able to create proper stitches, and that animal is not going to heal right.
One of the reasons students love taking an agriculture class is because it is hands-on. Not only are we learning content, but we have the opportunity to apply it with really interesting labs that are career-based, but also get students those hands-on opportunities.
So curve it around so that when it's secured, it's locked in this downward facing position.
That's one of the benefits of taking our CTE classes, is because students are really gaining a wide range of skills that are going to be helpful in a career.
When kids think of the farm, they're like, oh, the farm, you know, dirty and hard work. And it is dirty and hard work, but it's also a lot of fun. And just giving them the opportunity to be like, yeah, I did that. It goes a long way. And it builds them up as leaders.
One. There you go. these pigs are depending on you. Like, and it may only be for the summer, but animals are what I enjoy spending my time on. So I do understand the time commitment, and there are times that the pig has come before anything else, and I have like had to say like, nope, I'll be out of my pigs.
This is an amazing opportunity, and I never thought that I would be able to accomplish the things that I have. I've gained so much confidence and trust in people that are a part of this program.
It's always been my dream to work with animals, and now I'm able to pursue that. I would like to be a veterinary technician, and this program has helped me to be able to have more hands-on with animals and be able to help them.
I have fun, and then I learn money management, time management, and about sheep.
When you think about getting students career ready, it's not necessarily the skill. You can teach the skill, but having those soft skills that they can turn around and start a job tomorrow, working hard. Agriculture education is founded on the three-circle model. So we have classroom, FFA, and SAE. FFA is the leadership part, and with that we take students to conferences, college tours, and then SAE is their hands-on agriculture experience. Classroom is what they get when they're sitting in our classrooms, getting that science credit, doing the labs.
When I hold my hand out like this, we want this pointed down and around. Our goal with this class is to provide hands-on laboratory activities where they get the chance to practice real-world applicable skills. See if the veterinary field is something that they are interested in, and even if it's not, there's a whole lot of skills in here that transfer over to other careers.
Whether that is a student that really, really likes computer applications. Public speaking is part of our FFA program, and so that goes back to our three-ring model that we help make well-rounded students, because not only is it the classroom component, every student is going to have a supervised agriculture experience project, and every student is going to participate in FFA.
Walking him every day, constantly washing legs, managing his feed, making sure he doesn't bloat so much, and just making sure he's all fit and ready to go. Oh, it was totally worth it. I love this. I'm really excited. Last year I was looking to get a belt buckle, and finally I got one this year.
It's rare to get the success that you're looking for, and so for this young lady, her very last year of showing, to go out with a buckle, you know, that was her goal. So as an ag teacher, we want to work towards what their goal is, and storybook ending.
That's a big part in high schools, that ag and that program that they've got, especially out at North High. So thanks to those guys for showing us some of that. We do have Jacob, a third grade student from Whitley Elementary in school with us, but right now we're going to go to the phones. Malachi, how are you today?
Good.
And you are working with circles, correct?
Yeah.
All right, so go ahead and let's hear the problem that you've got.
It says find the distance around and the area of each figure around 10 years 10. And my question is a semicircle with a dot in the middle, and it says 8 millimeters.
Oh, so it's something different than what we've got on the board there.
Yeah.
Okay.
Could I, let me see that.
All right.
That's gonna help that. All right, so we need to find the nope, okay. So we need to find the distance around and the area of a semicircle, is that correct? Malachi, is that correct?
Yeah.
Okay, now when it says 8 millimeters, we're talking like that's the diameter, correct?
I think so.
Okay. So we need to find the distance around the semicircle and the area of the semicircle. Okay, so what do you know about distance around? What's the actual mathematical term for like distance around something? What do we call that?
Oh, it's, what's it called? Circumference.
Yes, very good. Do you remember the formula for circumference for a circle?
No.
Okay, so formula for circumference of a circle is 2 pi r. Now the nice thing is this already giving us a dimension here?
It just says 8 millimeters under the dot.
Correct, so but that's our diameter, and diameter has a relationship with radius. So radius, if I were to draw a regular circle here, radius is from the point in the middle to any edge of the circle. So now if I continue that over, it becomes the diameter or the distance all the way across. So remember, if radius is half of that, what would be the radius here? If the whole thing is 8, what would half of that be for the radius? What would, instead of 8 millimeters, say it again?
4.
Very good. So our circumference is now 2 pi, but instead of r for radius, we know the radius was?
4.
4, very nice. But unfortunately, we don't have a whole circle here, do we? We only have half a circle.
Yeah.
So this formula is for a whole circle. If I only want half of it, what else am I going to have to add to this formula to find half of the circumference?
I'm not sure.
If you wanted to cut something in half, what would you divide by?
2.
Perfect. We'll do the same thing here. When we're all done, we'll take it and divide by 2. So does your teacher allow you to use a calculator, or do you just use the shorthand like 3.14 instead of the pi symbol? How are you doing it in class?
3.14.
Okay. So if we were to do that,
And I was
circumference.
going to say, there's times when they might just go 8 pi.
Right. Just depending on how you want to do it.
Right.
So we can kind of look at this. So we can. That's where Mike's going with, where he says 8 pi. So we're kind of holding off on pi, and we're multiplying 2 and 4, which gives us the 8. Does that make sense to you?
Yeah.
Okay. And now we have 8 times pi divided by 2. All right?
Mm-hmm.
So now if we do 8 times pi, that's 8 times 3.14. That gives me 25.12. While you're multiplying that, tell me if that sounds about right to you.
What's pi what?
Pi is 3.14.
Mm-hmm.
And when you do 8 times 3.14, do you get 25 and 1200ths, 25.12?
Yeah.
Okay.
Yeah.
Now we're going to take that and do what at the end, because we only have half a circle?
What is the what?
Because we only have half a circle, remember we have to divide by
2.
2. So go ahead and take that, divide by 2.
Okay.
And what do you get?
12.56.
Nice. So 12.56, and we want to make sure our original measurement, our unit of measure, was millimeters, so we want to keep that in our answer. 12.56 millimeters. Sound good? Okay, now let's go back. We also need to find area, correct?
Yes.
Okay, so I'm going to erase all this. You all good with this?
Mm-hmm.
Okay. So again, semicircle, 8 millimeters is our diameter. Area for a circle is pi r squared. We already know the diameter, so remind me again, what is our radius if radius is half of that? 4, very good. So pi, now it's 4 to the second power. Well, Malachi, 4 to the second power becomes what? And that's like the same thing, 4 times 4.
Yeah.
Say it one more time for me.
16.
16, beautiful. So now we have pi times 16. But remember, this is only half of a circle. So what was that final piece that I forgot to write up here that we're going to put in down here if we only need half of the area because it's half a circle?
Divide by 2?
Divide by 2. I love it. All right,
All
so
right,
now we're going to do...
You got a minute to wrap that up.
Pi times
Calculate
16, 3.14 times 16. I get 50.24. Let me know if you get something different or if that looks good on your end.
I got the same thing.
Perfect. Now we still have to do what at the very end?
Divide.
Perfect. Let's divide by 2. Tell me what you get. We'll confirm.
25.12.
There we go. So our area of the semicircle, 25.12. But remember, we want to keep our unit of measure. We measured in what?
Millimeters.
Millimeters. And because it's area, it's millimeters to the power of?
2.
2. There we have it.
Nicely
Boom.
done, Malachi. Great problem,
Nice work,
and
Malachi. Great
nice
job.
that you guys could solve both parts of that right there. Pretty great phone call today. You've got yourself a meal courtesy of our friends at Grillenberger.
Nice. You get some math work done, get some points on the homework, and you get a meal. That's what I'm talking about. That's a good day.
Maybe I'll call in with a math problem sometime. We'll be back with more right after this.
A new crew launches to the space station. graduating a new class of Artemis astronauts. And a group of tiny lunar roving robots are ready to roll. A few of the stories to tell you about this week at NASA. On March 3rd, NASA's SpaceX Crew 8 mission launched to the International Space Station from our Kennedy Space Center. 2 days later, the crew, including NASA astronauts Matthew Dominic, Michael Barrett, and Jeanette Epps, safely arrived at the station. They will spend several months conducting scientific research aboard the orbital laboratory to prepare for human exploration beyond low Earth orbit and to benefit humanity on Earth. On March 5th, we held a ceremony at our Johnson Space Center to graduate a new class of Artemis generation astronaut candidates. After completing more than 2 years of basic training, the astronaut graduates earned their wings and are eligible for spaceflight, including assignments to the International Space Station, future commercial destinations, missions to the Moon, and eventually missions to Mars. NASA is accepting applications for our next class of astronaut candidates. Find out more at go.nasa.gov/astro2024. Engineers at our Jet Propulsion Laboratory are done assembling and rigorously testing 3 small robotic rovers that are slated to be delivered to the Moon by an Intuitive Machines Nova-C lander on a future mission. Part of our Cooperative Autonomous Distributed Robotic Exploration, or CADRE technology demonstration, the solar-powered rovers will work together to autonomously explore and map the Moon's surface. The goal is to show that a group of robotic spacecraft can accomplish tasks and record data as a team without explicit commands from mission controllers on Earth. Our James Webb Space Telescope has helped find the first clear evidence that the galaxy GNZ11, one of the brightest, youngest, and most distant galaxies ever observed, is hosting a central, supermassive black hole that is rapidly accreting matter. The finding makes this the farthest active supermassive black hole spotted to date. The galaxy, which was initially detected by our Hubble Space Telescope, existed when the universe was only about 430 million years old. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always fun things going on. All right, we've got 2 sets of numbers up there, Jacob. We got 5 plus 4 plus 3 plus 2 plus 1 plus 0. What does that equal?
Well, that would equal 15.
15.
Boom, there we go. 15.
What about the bottom?
Whoa.
Well, first we should add, or should I say...
Because you multiplied them, what did it all come out to be?
All came out to be 0.
How do you, because there's a lot of numbers there.
Yeah, on
right?
there's a 1, a 2, 3, 4, and a 5, and you got 0? How does that work?
Well, first we have 20 times 3, 60 times 2 equals 120 times 1, 120.
Bam.
But then we get the 0, which turns it into 0 groups of 0.
So even though we did all this work, got all the way to 120,
it's 0.
all because of one little 0.
That's what I wanted you to do, because sometimes students will look at that and it will say which one is larger at the end, and they think because you multiply that everything there is going to make it larger because they're multiplying all the numbers, but you did that beautifully. Did you learn a little something today?
Yes.
Did you have fun today?
Yes.
I'm glad that you showed us that Irish Riverdance thing too. That was pretty cool.
Got to get ready for Sunday.
Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.